Welcome back to the Restoring Darkness podcast. On today's show, I'm pleased to be joined by Dr. Brett Seymour. Dr. Seymour's research program is interdisciplinary and combines physiological, histological, and astronomical methods to understand the importance of natural light, as well as the consequences of artificial light on animal behavior and ecology of animals. Overall objectives of his research are to 1. Determine how light cycles have driven visual adaptations and predator-prey dynamics. 2. Quantify and investigate the myriad of effects and consequences of artificial light at night on animals, mostly insects, spiders, and reptiles, from the cellular to the landscape level. 3. Investigate visual and morphological, e.g. coloration adaptations, that render individuals more evolutionarily successful. 4. Develop techniques for quantifying light in a non-human and biologically relevant manner. 5. Quantify and monitor insect populations in the Chihuahuan desert. And 6. Utilize current biological research to increase learning efficacy in undergraduate courses. To accomplish these objectives, Dr. Seymour relies upon both field and laboratory work that ranges from electrophysiology of animal eyes, automated video tracking of animal behavior, and predator-prey experiments under natural conditions. If you've been a long-time listener of this show, you'll know exactly why we're interested to speak to Dr. Seymour today. If you're new to the program, this is an ongoing sort of discussion of how other living things are impacted by electric or artificial light at night. Before we go there, I want to tell you listeners about the Lighting in Darkness Foundation. It's a 501c3 charity. And we were created by the lighting industry, which is unique because most other types of institutions that work towards darkness restoration and night preservation are not from the lighting industry. But we at the Lighting in Darkness Foundation have come to understand that if this problem is going to be fixed, it is going to be fixed by us, the lighting industry. And so our mission is to change the kind of paradigm from the lighting industry to the lighting and darkness industry. And that darkness is also an asset that we can provide to communities, to parks, and to relevant cities. We're doing educational programs. We're producing this program. We're also mitigating light trespass disputes. That's right. We have 2 cases before the superior courts of various states, and we're coming in as a third party, not as an expert witness, as a third party to speak to the judge and say, this is actually a light trespass. It has nothing to do with nuisance. It's this company or this person is directly shining LED light on this other home. It is not a nuisance. It does not belong in ordinance law. It is a tangible encroachment under trespass law. And so we're working in that way as a third party, unbiased. We're not against lighting. We're from the lighting industry. And so we're doing those things. If you want to donate to us, if you want to help us out, you go to restoringdarkness.com, you click the donate link, and you can become a monthly donor. You can donate at a one-time fee, and you can even donate towards certain projects that we're working on. And then we'll use the money for that particular project. So go to restoringdarkness.com. Dr. Brett Seymour, welcome to the Restoring Darkness podcast.
Oh, it's great to be here. Thanks so much for inviting me, and I look forward to talking to you.
You know, I know that Dark Sky International talks about in their work that all living things are impacted by light pollution, and I agree with that. And can you tell me, first of all, how did you decide to take this path towards light and measuring light and how it impacts animals?
Sure. So yeah, my dissertation research was actually not focused on artificial light at all. Instead, it was focused on natural light conditions in the rainforest. So I was really interested in how animals evolve coloration and different visual systems to optimize being able to see in different light conditions. And I did this down in Panama and other countries in Central and South America, where I was looking at butterflies that occupy very different light conditions based on if they're in the forest or if they're out in fields, different times of day. And these light environments change drastically. And so I was out there for 6 years studying this. It was awesome. It was a wonderful experience. And then it was time to go on and get the next position. And so I was really torn by, and I'm out there enjoying these wonderful, pristine rainforests, but I would go to certain places the next year and those would be gone, right? They had been slash and burned. And so I started to think like maybe I need to do a little bit more conservation work in my career and protect these important light conditions that so many animals depend on, right?
Hmm.
And not just animals, but all organisms, as you said. And so I started looking for positions. I'd actually applied for one National Science Foundation postdoc to continue to do the work that I was doing. But I also found this postdoc through the National Park Service out of Colorado State University to study the impacts of artificial lighting on insects. Sorry, it wasn't on insects, it was on animals in general. And I thought, hey, I'm a light guy, but I'm a biologist. I'm not a lighting engineer. I'm a biologist. So I really understand and investigate how light drives organismal behavior. So I thought, well, this could be really fun. I also love the National Park Service. So I applied for that position, and the rest is history, as they say, right? So
Hmm.
I got that position. I turned down the National Science Foundation, which I'm not sure anyone else has done that. But I wanted to go into this more applied route, and I wanted to help the National Park Service because I'm very, very dedicated to the National Park Service as well. I've been to over 50 of the national parks here in the United States. And so this was a very close to home
Hmm.
opportunity. And so that's how I got involved. I didn't actually understand anything about astronomy at the time. I didn't know how astronomers were measuring light. They do it a very different way than a
Hmm.
biologist would do. But those tools are helpful. So I started to incorporate those into biological questions. And I'm trying throughout my career to kind of bridge the gap between these astronomers and light engineers and biologists. And I have found that a lot of people say like, these are two different species of people.
Hmm.
And so, they're doing their own thing. And I think there could be a lot more benefit from synergistic collaborations between these different camps. But to do that, you have to kind of understand both languages, right? Not that I am an astronomer or a physicist, but diving into how people use SQMs and other radiative transfer models, which most biologists don't even get close to. And then also talking to engineers about how lux and lumens is not really appropriate for anything outside of the human visual system, and
Hmm.
trying to push forward with how we can have more inclusive measurements as well as models to allow for a broad understanding of light, both natural and artificial, on ecosystems in general. So there you go. There's the long story. That's how I got to where I am now.
Well, I think your focus on bringing together different expertise is together is because we need electric light at night. Like there's our areas where we're going to need it, right? We can do
Yep.
much better, and we can help out in these other areas, right? So there's like it's not like this is why when the Lighting in Darkness Foundation sends a letter to a someone, it's like
Mhm.
we're not on anyone's side here. We're here to say that this is
Right.
responsible outdoor lighting or irresponsible outdoor lighting. That's all. And so I love the fact that you're bringing people together. And we've seen this happen. And I know, we're trying to do it on our end. Dark Skies is trying to do it on their end. And yes, until very
Mhm.
recently, would have not have any maximum light levels. They would only have minimum light levels. And so now you're starting to
Right.
see like the incorporation of maximum light levels into standards. And they're
Mhm.
working on glare metrics now because glare is unique from a perspective of animals and humans, and people perceive glare differently. So,
Mhm.
yeah, I mean, I think that's wonderful that you're doing that. I want to ask you a direct question that goes back right to your biography. Tell me about, and I don't know what to ask, but just tell me about these visual adaptations in the predator-prey dynamics. I don't want to like pin you down with a question. Just tell me what you
Yeah.
think we should know about that.
How much time do you want me to spend on this?
Yeah. We like the show. We've gone 10
So,
minutes. We like the show to go to about 45, but if it goes over, it goes
all
over.
right,
So,
perfect. Okay. I just didn't know, do you want the elevator speech or do you want the 3 month long semester lecture on it? So I guess to start that question or the topic, it's important to realize, right, that although we're highly diurnal organisms, right? We're active during the day, we're highly visually oriented, and our visual system is really focused on bright light conditions, which is why we have, this problem in the first place of artificial light. If we were more nocturnal, we wouldn't probably need artificial light at night because we would just be able to see with the light that's available. In fact, there is a lot of light that's available just from natural celestial bodies, as well as bioluminescence at night, right? But we can't
Mm.
see it. Our eyes are very focused on being more acute, and so we lose sensitivity, right? And we're cone rich and not so much rod rich. However, most organisms, especially nocturnal organisms, are the opposite. They have very sensitive vision to overall light intensities, but they have a trade-off with acuity and sometimes color vision as well. And so these animals that are more nocturnal or crepuscular, meaning that they're active during twilight, so dawn and dusk, uh, they cue in to these drastic changes in light levels. So during the day, right, it's a billion times. There's what, like a billion photons in the environment, literally a billion
Mm.
photons, right, in the
Sure.
environment, hitting one tiny little area, right?
Sure.
Billions of photons. And then when you go down to starlight conditions, right, the moon's not up, then you have a drop down to just 9 orders of magnitude less light in the environment, right? So this is not even linear. It's all orders of magnitude. It's all logarithmic. And a lot of animals cue into these changes. When it gets really dark, this is when they say, okay, now it's time to start hunting. Or perhaps the prey say, it's time to go hide, right?
Mm.
Because my predators are going to come out at night, or vice versa. And these predators and prey have co-evolved this under millions of years of selection, right?
Mm.
Natural selection. And they really cue into this. As far as I know, light cycles are the only cue, the only environmental cue that has stayed consistent for the last like 500 million years,
Mm.
right? Although the days have gotten a little bit longer, the overall relationship between day and night has stayed consistent. When you think of other environmental cues, such as partial oxygen pressure, right,
Mm.
or temperature, these things have fluctuated immensely, right? Immensely. We've had uh, climate change happen throughout Earth's history, right? You
Mm-hmm.
have what I want to say. You have the ice ages, and then you have global warming, right? And then ice age,
Mm-hmm.
then global warming. So temperature is always shifting,
Mm-hmm.
and oxygen pressures are also shifting all the time. So
Mm.
most of the things that we think like, oh, these are really important for animals are not actually very consistent, which means that these animals can deal with more rapid changes, whereas light has not changed,
Hmm.
right? The light cycle has stayed the same. It stayed the same.
Does
And
that
so now,
include the
yeah,
moon as
so go ahead.
well? Does that include the moon as well? Is the
Yep.
moon stayed constant? So
Yep.
the moon's rotation and its balance of the sun and the night and the way the moon works has been the same for 500 million years as well, or so.
Yeah. Or longer, right? I
Yeah.
mean,
Okay.
really, but life's pretty boring until about 500 million years ago.
Sure.
And so I just truncated it 500 million years ago. But as far as I know, the relationship between the sun, the earth, and the moon has stayed consistent for over 3 billion years, probably even
Wow.
longer, right?
Mm.
That's stayed consistent. Now, I will say that there's been some lengthening, right? So and I don't quote me on this exactly, but days have gotten longer, right? Back when the dinosaurs were around, the day was only like 18 or 19 hours long.
Mm.
And I believe the lunar cycle is also actually, no, I think that stayed constant. I don't know. We'll have to ask an astronomer on that. The
Sure.
point being that overall, the relationship between day and night has stayed consistent,
Mm-hmm.
right? It's not like, a long time ago, there were longer nights and shorter days.
Sure.
That has always stayed consistent just due to geometry, right? And because of that, animals have cued into this. I would make the argument that light is probably the most important thing for life on Earth, with the caveat of, well, perhaps also water and perhaps also um, oxygen, right? Oxygen and carbon dioxide. Those are both very important.
Mm-hmm.
But light is probably, if you remove any of these, you don't have life,
Sure.
right? It's gone. Uh, and people, I don't think they realize that for oxygen, and they realize that for water, because if we don't have oxygen or water, we die very quickly.
But they take light for
You
granted.
can lock someone in a right. We take life for granted,
Yeah, we take it
right?
for granted.
And
In fact,
we
I
could
would say
be,
that light is like
yeah.
kind of like the consciousness of the universe in a way. There's more in it. There's
Oh, I
information
like
in light.
this.
A lot of people don't realize
Yes.
like light is actually information, right? So when light, it's
Right.
energy, but it's also information. Like it's telling the Earth to revolve around the sun in a way. I don't know if that makes sense, but the waves of light and the waves of gravity, and even I would add to your little the thing where you said about the night and the light and the oxygen and the water. I would say even the moon's gravity on the Earth is like a stir
Oh
stick for
yeah.
life. It like stirs up the
Oh, I
pot of
agree.
life. You know what I mean? And we need that
Yes.
moon going
Yeah.
around, and those forces are I mean, light is those forces or something. And I hate. I want to get spiritual with a scientist, but there's something in the light that we don't know what it is yet. Totally, I would say. From all the podcasts I've done on
Right. I mean,
lighting and darkness, we don't really know
yeah.
what light is. That's what I would say.
We don't. I mean, that for sure, right? Everyone. Well, if someone says that they know what light is, they're full of it.
Okay, good. It's
Right? Or they just
confirmed.
don't. They don't understand it, right?
Yes.
Yeah, like they don't know. The smartest physicists in the world are still trying to understand because it's paradoxical and it shouldn't be able to be both a photon and a wave, and it's all
Yes.
beyond me. But it's all we don't really understand it. And you're absolutely right. Like the idea that it's not just energy, which by the way is our most important energy source, right? And so if you got rid of the sun, you'd have very few things that could live, right? There'd be a
Mm,
couple chemotrophs down deep in the ocean that would survive. Everything else would be dead,
mm,
including us. But we take it for granted, right? Because we don't
mm,
realize that those plants out there are just cranking away, making all of our sugar from light. A lot of people don't think about photosynthesis on a day-to-day basis, right? They should.
mm.
Every time you eat something, you should think about photosynthesis because that, whatever it is, either directly or indirectly came from
The sun.
light energy from the sun, right?
Mm,
Uh, but I like where you were talking about with the information. So that's really
mm,
that's where I focus more is that light is information and animals are cueing into this. And it's information of what the environment's going to be like for the next 10 minutes or the next couple of hours or the next few months, right? It
mm,
also gives seasonal information. So you can cue into that of when to migrate, when to reproduce, when to really stock up with fat reserves. All of this is coming from light. That's what
mm,
they're getting. Temperature
mm,
changes, it fluctuates, right?
mm,
So you really got to cue into to light. And that's why most animals, for their phenology, cue into both light and temperature. And I think people are giving a lot of credit to temperature and not as much to light. I think, which is, it's weird because light is so incredibly important and people just take it for granted.
Well, it's interesting
Not
in
to
the
say these
lighting
other things
industry.
aren't important.
Just on that point, in the lighting industry, we often have these linear scales, right? So, color rendering index,
Right,
right, for example, is one of these linear
right,
scales. Um, and when you're looking at that, it's the same with temperature. You don't really know what it's going to feel like outside if someone tells you it's 20 degrees Fahrenheit or 20 degrees Celsius. So you know what it's 20 degrees Fahrenheit would be cold, but 20 degrees Celsius. You need to know the
right.
humidity, the wind, all these other things that kind of affect that in a circle around it. So
Mhm,
individual
mhm.
linear measurements, I'm always a little bit suspect of, Brett. But yes, we got
Oh,
to
yeah.
find our way back to the predator prey dynamics because we're
Yes.
at 18 minutes.
So with all those cues, right? With
Yes.
all those cues, the
Yep.
light is cueing. Those animals are saying, okay, it's now at this light level. It's time for me to go out and hunt or
Mm,
avoid predators. And they've evolved certain sensory systems to enable and optimize their hunting abilities or their foraging abilities under those light conditions. And that's why the whole idea of a niche, right? So certain animals are occupying certain niches. And
mm,
I think it's really important to think of temporal or light niches. So these animals are occupying specific temporal light niches that have their own light environments. And that's the the prime time to go out, right? That's when they need to go out and hunt. That's when their chances of getting a food item are optimal. And if you disrupt these by putting them at a different time or all of a sudden blasting light in their temporal niche, which should, let's say they're focusing on full moon conditions, and
mm,
you put out a big floodlight, right, that just blasts and now makes it more like civil twilight, the animal is not going to forage as well. And perhaps you're actually going to shift this predator prey arms race in favor of perhaps the prey, or vice versa, right? You might actually, these prey that go out and say, okay, my time to go out and forage on plants when I'm most safe will be during twilight. But then you
mm-hmm,
blast light during twilight. And that actually is going to perhaps allow diurnal predators to continue to forage the same intensity with the same abilities and same efficacy as they were during the day, which is why their prey isn't active during the day. right? Their prey is active during twilight because they're trying to hide and trying to
Mm.
get under the cover of darkness. And this goes either way. So it just depends on which predators and prey you're talking about. But this is one of the papers that we actually published at the very beginning of this year, talking about how predator-prey interactions have evolved for specific light conditions. And when you shift these, and when you change either the intensity and or the color of the lighting, you're going to alter those predator-prey interactions that have been co-evolving for, again, millions of years. So there you go. There's the answer.
So, a good way to what popped in my head when you said that was when we talked, and I can't remember everybody's name. I can't pull it out of my head so quickly. So apologies if I've forgotten. There's a couple of researchers that I've talked to. They've shown that when there's a lot of high Kelvin temperature, 5,000 K lighting on the shore of a lake or something, it pushes the little fish out further, and they become more likely to be preyed upon by the bigger fish at night. And they can't feed as well because they're in deeper water and they get pushed out into the currents and stuff like that. And so there's like this effect of that light is having that effect on the smaller fish and actually crashing the populations of fish in certain lakes when people put high Kelvin temperature light close to the shore. And that would be an
It's
example
probably
of
out of
that.
Franz Holker's lab.
I think it was Zebula Schroer.
Absolutely.
Actually, Zebula Schroer is a
Oh, sure. Yeah, sure. Uh-huh.
Yeah. So I think it was. I think she's told me about that. So I could be wrong, but yes, I totally understand what you're saying. So you talk about mostly insects here, from the cellular to landscape level. But what are the myriad effects? Let's go through a couple of the effects and consequences of this on the insects and on other animals.
Yeah. So I like to go classic biology when I answer this question and think about it from different. What do I want to say? Orders of structure, I guess. So you can think of the impacts of light, both natural and artificial, from the cellular all the way up to the landscape, right? And so there's myriad things because you have these emergent properties that happen due to cells, tissues, organs, organisms, right? Populations, etc. And so if we just start talking about it, right, let's go with the cell. So there are certain cells that we have, that most organisms have, that detect light, right? So these are photoreceptive cells. And these photoreceptive cells, again, have evolved to pull out the important information from their environment. Sometimes it's incredible how good these photoreceptors can work. Other times it's just basically saying whether it's light or dark. But either way, it's super important to that animal to know that information, right? Just because they have this maybe more ancestral photoreceptor or eye type doesn't mean that it's not important. It just means that that's all the information that they need. And so you have these cells, and in these cells you have these molecules called opsins, and these opsins detect the light. These opsins are sensitive to only specific wavelengths of light. And why I say opsin is because that's what allows us to see color. So we have different types of opsins in our different cones, and animals have different opsins that allow them to perceive different color. So if you change the light environment, you're actually changing what opsins are going to be detecting light, which is then going to change the contrast that the animal is seeing in its environment. So if you have a very, let's say, an 1800 Kelvin light compared to a 6,000 Kelvin, right? So this is red and blue respectively. If you have those two, it's going to change how the photoreceptors that are sensitive to red light, as well as the photoreceptors that are sensitive to blue light, how they're firing. And this is going to change how the animal is literally perceiving its environment because the light has changed. And that's happening at the molecular and cellular level. Another really important opsin is called melanopsin. And have you heard of melanopsin?
No, I haven't heard. I have a suspicion of what it is, but I haven't exactly heard the term before. But please go for it. Tell me all about it.
Yeah. So what do you think, right? So melanopsin, what do you think?
Melatonin is something to do with melatonin and sleeping. Yes. Yeah.
Of course.
Yes.
Yes. So melanopsin is the opsin that then fires and tells the brain, hey, right now I'm catching a lot of blue light because melanopsin is sensitive only to blue light. And says, hey, I'm firing a lot right now with blue light. Do not secrete melatonin. When melanopsin is turned off, aka no blue light in the environment, it says, hey, guess what? There's no blue light in the environment. It must be nighttime, right? Because blue is very, very abundant during the day from the blue sky. There's tons of blue light in the environment. During the night, no blue. So then the brain says, okay, Melanopsin is no longer firing. That must mean that it's nighttime because there's no blue.
Mm-hmm.
And we're going to start secreting melatonin. And melatonin then has all of these cascading effects. It literally slows down your metabolism. Obviously, it makes you sleepy and gives you good rest.
Mm-hmm.
It also leads to the immune system. So, melatonin is needed for a healthy immune system, including fighting off cancer and other tumors.
Mm.
All these things are from melatonin. And
Mm.
melatonin completely comes from whether your melanopsin is firing from blue light or not. And this is why we have so many issues. Now, there's other reasons too, right? It's not just melatonin and melanopsin, but obesity,
Mm.
sleeping pathology, right? Both
Mm.
insomnia and narcolepsy come from melatonin disruption. And
Mm.
this is likely we're seeing a lot of this because people are exposed to blue light much later than they should be, right? Much, much later than they should be from screens and everything. Blue light's not necessarily bad. It's just,
The timing of it's
you know,
bad.
there's a time for it.
Yeah.
Exactly. So
So,
I always tell people, yeah, go ahead.
yeah, I know. You always tell people, and then I'll ask you a question after that.
Oh, yeah. So I always tell people, right, like blue light, you want to have, you know, around twilight, you want to stop having any blue light, right?
Mm.
Go all amber, go below like 3000 K.
Mm-hmm.
But in the morning, especially if the sun hasn't come up yet, right? Let's say it's the winter, you know, in the northern hemisphere,
Mm-hmm.
and you want to wake up, you should have a blue light, like a 6000 K, even
Mm.
greater, like 7200 K,
Mm.
turn on at the time you want to wake up and flood your room with blue photons because your brain is going to detect that through melanopsin not firing and say, hey, I got to, or through melanopsin firing and say, I got to shut off melatonin, right? It's daytime. It's time to
Mm.
wake up. So you want to have blue light early in the morning and then no blue light, you know, in the evening time. And this is because, again, this cascading system of the physiology of organisms that's dependent upon circulating levels of melatonin.
So we've had about 150 years of electric light. Okay, right?
Mm-hmm.
Going back to Edison, right? And
Yeah.
in the beginning, light pollution was beautiful, man. Like, look at the Eiffel Tower.
Right.
I'll admit it. Sailing down the Seine River in
Right.
Paris, looking at the Eiffel Tower, that's magical, man. But they turn off all the other lights around it
Right.
just so you can see that one tower. Okay. So light
Right.
pollution was beautiful when we started this whole thing a long time ago. But, you know, with and HPS was an accidental mitigation. And low pressure sodium and high pressure sodium were the lighting industry stumbled upon accidental mitigations to light pollution by developing those technologies. And then,
Right.
you know, there was some metal halide, but largely our municipal street lighting would have been low pressure sodium and then high pressure sodium, just because of the energy advantages of sodium based lamps. More energy efficient than metal halide, last longer, they don't fade as much. There's a lot of good things about low pressure and high pressure sodium that I think people don't understand or recognize anymore. Even though they were mercury lamps, they were very good for the environment in terms of light pollution, or less damaging, say. And then you talked about these 9 orders of magnitude. And I feel like the advent of LED, with the automatic thing being 5,000 Kelvin, lumens per watt was the only thing that mattered. And the more uniform, the better, right? So you have this deployment of energy efficient technology. And I think we would both agree that there are environmental benefits to less energy use. Yes, we agree with that. But we increased light pollution by a magnitude, and the worst kind of light pollution, which is high blue light pollution, which is on at night and at dusk.
Right.
And
Right.
you know, I think we're in a event that's only like 9 years old, maybe at the most. So we have 125 years of HPS and incandescent and low pressure sodium, a little bit of metal halide mixed in, which is 4,000 Kelvin, and then all of a sudden, an explosion of high Kelvin temperature, glary, high brightness, laser beam style light fixtures that can penetrate miles into the ocean. And
That's right.
that was never possible with HPS or metal halide. But a 300 watt or 500 watt LED light fixture mounted on a it's like laser beams, and it penetrates. They measured it.
Yeah.
It goes miles. It goes out miles into the
Right.
ocean. How do we have any sense of how bad it's getting? Do we have any signals that maybe we've done a lot of damage very recently, or are we still working through what happened in the last 100 years?
That's it's a great question. And yeah, I'm really glad that you point this out too, because it is really important to think about the historical ties to high pressure and low pressure sodium lamps. So I have one study that was published last year where we actually looked at how the foraging of birds on insects is altered under high pressure sodium compared to 5,000 K LEDs,
Mm-hmm.
right? And we found that, in fact, yeah, a bird is more likely to eat a moth if it's under 5,000 K LED. This makes sense, right? There's higher
Mm-hmm.
contrast. Uh, high pressure sodium is actually, it's very long wavelength dominant,
Mm-hmm.
and it makes things relatively cryptic because it's just, a brown moth under a reddish brown light against a brown environment is just going to blend in. And so birds are not going to be able to see it. And people are going to say, well, wait, birds aren't going to be attacking moths at night. Well, actually, they are because of all this light now and all the blue light from the LEDs. A lot of birds in urban environments are actually foraging hours before sunrise, as well as hours after sunset because of this disruption of melatonin. So the birds are actually one of the main predators now at night on insects. And our study showed that, right? We put out these 500 different models of moths, and we had about uh, what was it? Around 18% of them attacked only by birds. So not even bats, but by birds. Anyway, so this is going to your point, right? We know that there's now different predation pressures on these insects and other prey items that have actually been evolving to be cryptic under red light conditions. So you mentioned high pressure sodium, which is red, but also before that, it was starlight. Starlight is red, right? Starlight is actually red at night. And so these animals, again, like it's good to be under a red light. And that's what we found. And then it's not so good to be under blue light. However, this was only in Fort Collins, Colorado. We don't have data across the globe or anything. This is likely going on everywhere. And so, likely, a lot of prey items are actually having the balance tipped in favor of the predator due to this changing light. Also, one thing we do know, another thing that's changed is that the predators now they're hungrier and they're more active. And the reason they're hungrier is because their melatonin is not firing as much because they're being exposed to this blue light. So they're hungry. And so they literally eat more because their metabolism is higher.
They're getting fat like us.
Exactly. Yeah. Well,
Okay.
they're not getting fat because they're more active, right? So
Okay.
they eat more and they hunt more. And
Okay.
so they're just more and more active. They're active during the day, and now they're
That's
active at
because they don't
night.
have an
So they're
iPhone
just
yet.
less
Wait till the
active.
animals start getting these
Exactly.
electronic devices.
Exactly.
Then
That's right.
they'll become
That's right.
sloths like us. Do you know
Yeah.
do you know Yash Sandhi from Florida International University?
Yes. Very well.
So we
We're
just
good friends and colleagues.
Yeah, so he blew my mind when he told me about the not the bats, the moths orientating upside down to the light and getting stuck. The poor moths. I mean, it used to be the turtle, then it was the
Right.
bat. Now it's the moth that's really the symbol of this movement. I mean, we're decimating the
Yes.
moth populations with light
Yes.
pollution. From the predation perspective by birds, and as you've suggested here, and then also by killing them, straight up killing them with the light pollution
Yeah.
because they can't stop
Or
flying
disrupting
around
their
in a circle.
navigation.
Yeah.
Right. Yes. Exactly. Yeah. Yeah. So, I'm glad that you had Yash on. Is that podcast been published yet?
Yeah, it's out there. It's number 98 from a couple weeks ago. And
Okay.
he's also helping us
Excellent.
with a
I'll have
little
to
bit
check
of
it out.
educational work. He gave a great presentation to our educational committee about the moss. And everybody, nobody thinks about moss. Everybody wants to save the cute animals. But like
That's right.
it's like a genocide of these poor moths and birds, man.
Yes.
It's really
Yes.
it's really disgusting actually when you start to dig into it. It becomes very macabre, the light pollution piece.
It does. Yeah. Yep.
It's like a big
Yeah.
death
And the other
wave.
thing, it is. Yes. I mean, it's a great way to just wipe out entire populations of moths and also mayflies. And you're right. Most people don't care about moths, but moths, they're super important for pollination. This is actually I study moths, and Yash and I have several studies that are ongoing right now. The thing about moths, though, is that, and this is what the main species that Yash studied were sphingids, which are also called hummingbird moths. And I bet the average person actually thinks that these moths are birds because they're
Mm,
big. So they're like this big.
hmm
And so for people that can't see me, right, it's probably about anywhere from maybe 2 inches or about 5 centimeters from tail to head, right? So
Mm.
these are big moths, and they hover like hummingbirds, and they feed with a super long tongue or a proboscis, just like a hummingbird. And in fact, I was having dinner with my fiance 2 nights ago outside, and one of my sphingid moths flew right in between us, right outside on our table. And I was like, "Oh wow, that is amazing!" And she was like, "Oh, a hummingbird." And I was like, "No, not a hummingbird.
Huh.
That was a moth." And I
Magical.
was like, "You can also hear it. So like a moth, you can't hear it, but a hummingbird you can hear it." And it was, and she thought for sure it was a hummingbird. She also quickly gave. She knew she wasn't going to win an argument with someone who studies hummingbird
That's
moths.
tough.
But my point being that I think these moths that Yash is studying, that I'm also studying, these are the charismatic, cute animals that we need to have people realize, right? These aren't the
Mm.
moths that are eating your clothes during the winter.
Mm.
These aren't the moths that are a nuisance. These moths are actually adorable, and you can hold them in your hand, and they have these big beady eyes. They are like the puppy dogs or the bear cubs of the insect world. And I think if we can get our message out more on these really important moths, these big moths that are a lot of the biomass of insects, as well as key pollinators, huge ecosystem service providers, uh, people will start to realize, like, oh, maybe I should turn off my light because it's going to kill some of these big, beautiful hummingbird moths. And I
Mm.
want to stress hummingbird moths because everyone likes hummingbirds. But yeah, so that's great that you talked to Yash, and it's terrifying of how well light is killing off these insects.
Well, I also read an article, I can't remember where it was, but it talked about how we domesticated animals that we eat and we feed on their eggs and all that sort of stuff, but we also domesticated our pests, right? Like the moths that are in your
That's right.
clothes, that's a human domestication of the moth in a way, in a bad way, but like they've become part. So we're not talking about like cockroaches and this sort of stuff. Oh, cockroaches play a role too in certain
Right.
instances, right? At the bottom of bat caves,
Right.
cockroaches eat all the bat poo.
Yeah. Yeah.
You know what I
Right.
mean? It's like they're part of the
Right.
system.
Yep.
But yes, you're right that those moths, I didn't realize how cute they were. He didn't point that out. I'm going to talk to him
I'll have
about
to. Yeah.
that.
I'll have to send you a photo. They're really quite cute.
That's
I
cool.
should have one in here to show you, but yeah, they're great.
Uh,
So, but I do want to bring back your point, right, about the importance of LEDs. And I give a lot of talks, mostly to very environmentally focused people, right? My students would call them the granola people, right?
Sure.
And they pretty much, if I gave them a survey at the beginning, right, are LEDs bad? I All of them would say absolutely, right? LEDs are the worst thing on this planet. Like they're terrible. And I have to quickly tell them, like, LEDs are not bad. LEDs are by far the best lighting that we have ever created. They're incredibly what do I want to say, energy saving, right?
Efficient. Yeah, energy efficient. Yeah,
They're
sure.
one, yeah, energy efficient. Thank you. They're wonderful lighting, way better than anything else that we have, and they're completely tunable. The problem that we have with
Mm.
LEDs is that most people are getting light that they shouldn't be getting for nighttime, right?
Mm.
And then they stick it out there with no fixture and they just have it blasting, right?
Sure.
Way too much light because it's cheaper now, so they can do more and they can just have it be brighter, right?
Well,
Oh, look, I've already spent this much
I'll make
money
the
in the
point.
past, and
Our light trespass mitigation efforts are totally related to this. The person couldn't create this light trespass because they wouldn't have the electrical infrastructure in their home to do so. Because in the old
right,
days, they would have had to put a 1500-watt metal halide light fixture up. That's an
right,
enormously heavy, huge light fixture, right?
right,
And it
and very
still would not,
expensive,
yeah, very expensive. And like you need a 20 amp circuit breaker for every single one of those.
right,
You understand? Or
right,
a 30 amp circuit
right.
breaker.
Oh
Now
yeah,
you have one 20 amp circuit breaker. You can put, six 300-watt LED light fixtures that are just creating 400,000 lumens. And
right, right,
it's almost like I'm serious with you. It's like Javon's
right.
paradox, right? It's
Yeah,
falling
yes,
right into Javon's
yes,
paradox, right?
yes, yep,
And
yep.
so yeah, there's an element of the Lighting and Darkness Foundation that is created because of LEDs and because
That's right,
we need to tell people, and judges don't know how to make these decisions. They think it should be an ordinance
right,
law, but it's not an
right.
ordinance law. It's actually a trespass. It actually is a tangible encroachment.
Yeah,
Um,
I
let me
agree.
ask you about the the quantifying, where is it here? The developing techniques for quantifying light in a non-human and biologically relevant manner. What do you mean by non-human and biologically relevant?
Sure. So the human visual system, right? We have three different color photoreceptors, cones, and we share this visual system with only a handful of other animals, and those are the other apes, right? Otherwise, no animal has the same visual system as us. But when we think of like the photopic curve, that is focused completely on our three cones and where our peak sensitivity is based on our three cones, those being the red, blue, and green. And so astronomers and physicists have focused because they care about human perception, right? They have focused on developing all these mechanisms or all these measurements that are dependent upon our three cones in that photopic system. This is where lux and lumens come from, right? I try not to talk in lux or lumens unless I'm talking to someone that knows lux and lumens, because it's lux and lumens are only pertinent to human visual systems and a few other apes. That's it. Lux does not work for any other visual system. This is why plant people have PAR, which is the photosynthetic active radiation, and this is kind of the photopic system for plants. But people that study chickens actually have this thing called clux, which I think is absolutely brilliant. It's called clux, which I love, and it's actually the double cones of chickens, which is what their photoreceptor for light intensity is this double cone. So it kind of looks like if you put the blue and blue and green one together, that's what their photoreceptor looks like. So anyway, there are all these different visual systems, and in insects, it's incredibly diverse. And in fact, in the ocean, it's even more diverse. You have these stomatopod, these mantis shrimps that have like 16 different types of photoreceptors. So they're seeing the world insanely different. So to come up with a measurement that you can apply any visual system to, you need to measure from 300 nanometers to about 750 nanometers. And if you can measure, so this is just a classic spectrometer, right?
Mm-hmm.
If you can measure all the light and the intensity of each wavelength, then you can apply that measurement to any visual system you care about. And if you care about overall lighting, right, you just take the integral of the curve and you can get the overall amount of photons in the environment. And this is what we need to be pushing towards, because it gives us so much more information and allows us to apply the light to any photoreceptor, not just visual systems, but any photoreceptor. Problem is that they're expensive because there's no market for it, right? There's a few biologists that want these things. They're also not very sensitive. So when you want to take them out at night, they're meant for daylight measurements. You take them out at night, you have to have it run for an hour, and it still doesn't really give you enough signal to noise ratio. So these are things we're trying to work on, is how do we take what the astronomers have already made that works well for the human visual system and tweak them so that we can actually study light that's appropriate for all visual systems and all photoreceptors.
Oh my goodness. That sounds like a big undertaking.
It's a big undertaking.
Right. Yes.
Yeah. And I have engineers and physicists say, like, it doesn't matter. It's all going to be correlated. It's not. Because if you only see in the UV and you're using the lux, well, lux is going to tell you 0, even though UV is immensely peaked, right, in some environment, like if you have a metal halide or something. And so it's not correlated. We actually do have to measure these things. And infrared, a lot of these light sensors actually measure infrared as well, which animals don't see. So you're getting these lux measurements that are actually skewed because there's infrared in there.
Mm-hmm.
That's a whole other story for another time. But this is the stuff that we're working through.
Well, I mean, infrared light is certainly emerging in the lighting industry now as having a major effect on on human health and wellness. And I don't know how it would be for moths, but I'm suspecting the same thing. Like there's a reason why people in northern climates all have some sort of sauna or some sort of hot rock treatment,
right?
Because that's the same. That's that same wave hitting them, right? And so it's not a coincidence that they all do this in northern cultures, because it triggers that vitamin D production and all that sort of stuff that's happening when infrared hits your body. And so there's a whole rabbit hole there. Is that light or is that heat, or is it the same thing? You know what I mean? That's where it becomes difficult. Like at the fireside, we evolved at the fireside, and is it the light of the fire, or is it the heat of the fire, or is there something totally else going on there that we need to understand? Why do we feel comfortable beside a fire? Why do we want to feel safe there? Why do we want to be close to one another? Why do we calm down? Why do we want to go to sleep? Why do we want to make love? These things that happen around candlelight and
Right.
firelight. These are not things that women or men came to like because they discovered them. These are deeply built inside of our
Yes.
evolutionary systems.
Yeah, that's right. Yeah, absolutely. Uh, and have you had Chris Kaiba on your
I
podcast?
have, yes. Yes, I
Yeah,
have.
yeah. So Chris Kaiba and I look forward, if he hears this, I look forward to furthering this conversation when we are in Austria for the Light Pollution Theory Modeling and Measurement Conference in July. But he and I have gone back and forth about that exact question, right? Which is, when is it light and when is it heat? And as a biologist, I say, well, it depends on what your sensor is, right? Are you measuring it with a photoreceptor? Or are you measuring it with a heat receptor? And
Mm,
so rattlesnakes, right? They can see infrared,
mm,
but they're not actually seeing infrared. They're detecting heat, and they have a very different organ for this. It's not measuring the photons, it's actually measuring the heat vibrations on basically like an eardrum. That's how they sense this. So it's nothing like a photoreceptive system. Instead, it's actually like an acoustic vibratory system. And so I would say, like, well, they're not seeing the infrared, they're feeling the infrared.
mm,
And but then Chris will say, but who cares, right? The energy disturbance is still electromagnetic radiation, and there's photons there, even if it's heat, and it doesn't matter, right? And this is exactly the difference between a physicist and a biologist. Is I'm saying, well, wait, how is it actually being measured by the animal, right?
mm.
And if it's not queuing into photons, well, then I don't think it's safe to say that it's light. I think it's safe to say that it's heat. And both light is heat. So electromagnetic radiation is heat, uh, just at different scales. But yeah,
There's
so this
there's
is
a
something
there's a
that even the
zone of
physicists and
transition.
biologists.
There's definitely a zone
That's
of
right.
transition between light and heat that is extremely important that we need to understand better.
Yes.
And
Yes.
we know that all of these things can hurt us or help us based on the dose and the time of the dose. And and
Right.
we're not, they talk about, there's another term that's floating around the lighting industry. You might be interested in this as well. Light hygiene, right? Getting your light
Yeah.
hygiene
Light
right.
hygiene. Uh huh.
Yeah. And I think
Yes.
that's an
Yeah.
interesting
Exactly.
perspective to it where people, I don't, 7,000 Kelvin blast of light in your room. No, most people are not going to have access to that, Brett. You know what I mean? Most people
Right.
need to go
Right.
outside and walk the
Right.
dog in the morning or something to get that blast.
Yes.
It's very
Right.
important.
Right.
And, it's interesting. I want to ask you one more question here. In my travels through this pod, and we've gone almost 50 minutes, if you can believe it already, just like that.
Yeah.
Um, on this journey through this podcast, I've talked a lot about circadian rhythms, and I think that to me, it seems like getting a good night's sleep is the thing that creates all the other downstream health benefits. Everything else that they relate to good light hygiene is actually as a result of sleeping well. Would you agree with
Yeah.
that?
1,000 billion%. I could not
Okay.
agree more with that. I just like you are, right? We're super busy people, and I'm incredibly busy as an assistant professor. There's one thing that I do not mess around with, and that is my 8 hours of sleep. No
Mm,
matter how busy I am or what priorities, it's 8 hours sleep. And that's because I completely agree with you. And we know this, right? We know this from science that you need 8 hours for everything else. Why would you wouldn't, like, use, I don't know, like super old oil or something in your car, right? You would
hmm
always make sure that you're maintaining it. And I think the 8 hours of sleep for us is the most important maintenance. So yes, and also having that good sleep hygiene and light hygiene, right, where you can fall asleep easily to get that 8 hours. So you're not just laying there not sleeping because you watch TV too late, or
mm.
you were on your phone without the red shift on it. So could not agree more. And I was bad about this as an undergraduate and even a bit in my PhD, right? I wouldn't sleep as much as I should. And then, of course, you have to take naps during the day and you can't think as well and you've got brain fog. And then I read this book about the generals during World War One. And I can't believe I'm forgetting his name, but the French general, who they say is like the reason France didn't lose to
Mm.
Germany in World War One,
Petain?
he every night from 10 o'clock to, sorry, what's that?
It's General Petain, I believe, is it not?
It was Patan. Thank you.
Yeah.
Yes. Yep. It was General Patan, right? Every night, no matter what was happening, he would sleep 8 hours. And he told everyone, unless they're breaking into my house, I don't want to know about it. Right? Do not wake me up. I'm to
Hmm.
sleep 8 hours, and then I'll deal with it when I wake up. And I was like, well, look, if a general who's fighting in World War I could say, like, I'm going to protect these 8 hours because I
Hmm.
need to win the war, then I think we should all do that, right? We should all say, like, okay, I can carve out 8 hours where I'm sleeping, and focus on the light hygiene so we sleep really well. Yeah, I could not agree more. I mean, I just preached about it. So
Yeah, yeah, no, and it's interesting. I'm an early riser, and like I like to get up at 4 o'clock in the morning, 3:30, 4 o'clock in the morning. That's the right time for me to get up. And people would say to me like, "Oh, how do you do that?" It's because I go to bed early. That's why.
right,
There's no trick,
right,
And I
right,
tell my kids, I got four
right.
kids. I tell them not sleeping enough is a self-inflicted wound. That's a
Yes,
self-inflicted wound,
yes,
like a sunburn.
yep,
You know that you're,
that's right.
been in Canada, you're all pasty white. You don't want to lay on the beach for 8 hours when you get to, Cuba
That's
for
right.
the week that you're there. You're going to get it's a self-inflicted wound, right? Not getting enough sleep. It's like a hangover. You drank the booze, you get the
Yeah,
hangover, right? And
absolutely. That's a
and I,
wonderful metaphor for it.
the other thing too is that there's almost like a bravado around sleep, where especially in the Silicon Valley crowd, where there's this like legendary Adderall. He's working all the time and
Right,
he's always available and he only sleeps 4 hours a night. How does he do it? That's
right,
all BS. Okay, that guy's gonna die if he only sleeps 4 hours a night. He's gonna
right,
die really young.
right. And he could
Okay,
be more productive
yeah,
if he
he would be
slept
more
more.
if he slept 8 hours.
Right. Yeah,
It's
he'd be more
there's no
productive.
humans are like you said earlier on this. Humans are not a nocturnal. We're not nocturnal animals. Okay,
Correct. We're not. We're not.
and
Yep.
so wow.
I agree.
I think you and I could probably keep riffing on this for another 2 3 hours.
Yes. Yes.
But I want to be courteous to our listeners and viewers that watch the show, and hopefully we'll have you on again, Brett. And
Yeah, I look forward to it.
so that was Dr. Brett Seymour, folks. Wow. I don't see any social media here in his here it is here,
I do have,
brettseymour.com.
I have
Yeah.
an X too. It's just Brett Seymour. Uh, yeah. So
So
I
go to the
am on
Restoring
Twitter.
Darkness podcast website. It'll be linked all there for you. You can click it and see his stuff there.
Perfect.
And of course, folks, if you want to donate to the Lighting in Darkness Foundation, you go to restoringdarkness.com. You click on the link there, and you can support our work. Light trespass mitigation. This is groundbreaking. A lot of people have been talking about, what are you talking about? Well, in the age of LED, we can now afford the light fixtures are cheap. They don't use that much energy. We have the electrical infrastructure, and in the average 100 amp circuit, 200 amp circuit, people can light up their backyards like commercial parking lots, and it's devastating for their neighbors and for the wildlife and for a whole bunch of reasons. And so we're trying to get these judges to move this out of ordinance law, out of nuisance law, and into trespass law by showing them the tangible encroachment using photometric reports. This light fixture puts 40% of its light on this person's property, and this person has not given permission to have their property illuminated. This is a trespass. And so this is what we're working on down at the Lighting in Darkness Foundation. We're also making our Darkness Specialist 1 educational program. We're doing it right now. We're in the process of development. This is lighting education, darkness education for lighting people. That's right, frontline lighting practitioners, distributors, contractors, agents, these types of folks, people that sell lighting to the end user where it's so difficult to talk to them about less light. We want you to pay more money for less light. No, man, just give me those 5,000 K ones like the neighbor over there. I want to blast this whole area out. So, folks, if you want to help us out, go to restoringdarkness.com, click the donate link, and like, subscribe, share, but also thank you from my heart for listening to this show. That's the most important thing, is that we get the word out. So thank you for listening. Bye for now.